So we will solve this one and we will graph it and put it in interval notation just to cover all our bases, okay? So on this one, first thing we need to do is solve for the absolute value, right? So let's get rid of that minus 10 by adding 10 to both sides. That zeroes that out just as we want it to. Now we have 5 times the absolute value of 9x plus 7, which is less than or equal to 40. And then we need to get rid of or make that 5 just a phantom 1. So divide both sides by 5. Now we're dividing both sides by positive. That's good. And then we're left with the absolute value of 9x plus 7, which is still less than or equal to, but now 8. All right, now that we have this inequality, we're going to split it up. You could write an and statement if you wanted to. Like, that's perfectly acceptable in my book. But really what we want to do is we want to sandwich that. But okay. Well, we're going to sandwich that 9x plus 7. Yeah, I don't know what's going on with the technology, but so we're going to say it would just be less than or equal. It could be less than or equal to 8. But now we also need to say that it could be greater than or equal to negative 8, okay? So this is one of those inequalities where you have to sandwich this between this value and its opposite because it's not eating the absolute value, okay? Now that we know that, let's solve this, okay? Now this is an inequality in 3 parts. I think they call them tripartites, but I also assume you don't care. Okay, so whatever we do to one of these, we got to do all 3. And we want to isolate that x and get it by itself, and we also don't want 9 of them. But I definitely don't want that plus 7 there, so I'm going to subtract 7 from not just both sides, but all 3 parts here, okay? So on the left, negative 8 minus 7 is negative 15. The 9x, of course, we can just drop. We zeroed out the positive 7, which was what we wanted, and then 8 minus 7 is 1. So this is not going to change the inequalities, so we're going to keep those. And then next up, the last thing I'm going to want to do here is to make that coefficient of x a phantom 1. Okay, so you make it a phantom 1 by taking the coefficient of 9 and dividing it by itself. But if you do it to one part, you got to do it to all 3 parts for this. So on here, I'm dividing all the parts by a positive value, so that's not going to change the inequalities. On the left, I got negative 15 over 9, which will simplify to negative 5/3. And then the 1 divided by 9 is just 1/9. And I'm going to keep the fractions here because the decimals are long and ugly, in my opinion. But, well, they're not too bad. So now I'm ready for the graph on this. So if I had 0 here, 1/9 is positive. I think I got that right this time. And then negative 5/3. Let's make these big again. Negative 5/3 on the left. And so with the negative 5/3, you could say that it could equal negative 5/3. That's okay. And then the 1/9 as well. But the x is sandwiched between, so it's just everything in between this. I should need a little bit more space for the interval. So starting at this graph starts at negative 5/3, which is included, and it goes all the way to 1/9. And that's where it stops, which is also included. So this is my interval right there, the graph, and we have the inequality too. Okay, now the other way to do this would be to start from back here, and we're going to separate this into 2 inequalities. We just need to remember that it's an and statement. So the first inequality takes the inside, 9x plus 7, and it just remains the same inequality here. But less than or equal to positive 8, right? But the other one, 9x plus 7, it would be compared with negative 8, and then it flips the inequality. Then we can solve these 2 inequalities with some principles of equality. So you see we get the same answers here, but if you're going to do it this way instead of the 3-part compound inequality, just make sure you put the word and between the 2 inequalities. But there you go. That's a second way to do it, just like we have been doing them instead of making this tripart inequality. You see we get the same answer. In the end, you'd graph it the same way, and you'd end up with the same interval. We were looking for the interval on this one. We do have the graph, and we have the inequality in 2 different formats right there, but both work.